Hi everybody, my name is Alessio Trevisan and I'm SDC Verifier Product Manager here at EngineSoft. I work on offshore construction department since 2007, where I used to calculate special structures for that field of activity. During my career, I encountered many rules and standards like Eurocodes, ASME, AISH, ABS, DMV, only to cite some of them. You know, it is truly difficult to handle code checks by hand calculation or even with spreadsheets. And this is why we welcomed SDC Verifier as the final tool to complete this task. So I'm very happy today to introduce you the Chief Operating Officer at SDC Verifier, Oleg Ishkuk, a true expert of that field. Oleg has a great experience in mechanical engineering, in particular structural verification of ship-to-shore cranes, lifting appliances, floating structures, vessels, and other equipment. It is also an expert in structural verification according to multiple industry rules in oil and gas, offshore and maritime, civil, heavy lifting, machinery, and other industries, focusing on fatigue, plate buckling, and member checks. Today, we will focus on the verification supported by simulation, which is also the title of this webinar. After this speech, there will be the possibility to make some questions. But now I give the floor to Oleg without further hesitation. Welcome, Oleg.
Okay, thank you. Thank you, Alessio, for the introduction. And yes, hello and welcome everybody. So let's proceed. Let's start with a brief agenda of what we are going to speak about today. So first and foremost, we'll start with an introductions. I will point out to some of the workflow problems. I will explain you the workflow of SDC Verifier solution and how SDC Verifier helps to tackle these problems. And we'll have some benefits and conclusions discussed, as well as we'll have some time for the questions in the end of this session. So Alessio already did quite an extensive introduction of me. Just a quick reminder, my name is Oleg Ishchuk. I'm in charge of operations at SDC Verifier. I have about 15 years of experience in structural engineering and simulation software, focusing on multiple industries, mostly those which are where checks according to standards are very important or even obligatory. So offshore, oil and gas, energy industry, machinery, equipment, civil engineering, and so on and so forth. Multiple different structures has been in portfolio of SDC Verifier, and I had a luck working with great engineers on different types of projects. And we focus on different failure modes as fatigue, plate buckling, member checks, weld checks, bolted connections, and more. Yeah. So now a bit about SDC Verifier. We are partner of EngineSoft in Italy, and we are a Dutch company with headquarters in Haarlem in the Netherlands. We are the company was started as a single guy engineering consultancy company in 1998 by our current CEO and owner, Wouter van den Bos. He was delivering engineering consultancy projects, and he was struggling with manual and repetitive workflows. So since 2009, we started developing engineering software, which helps to tackle the problems of structural engineering and which help to deliver automation to improve engineering workflows. We have more than 30 people in 3 offices around the world, and most of the company are structural engineers and software developers. More than 200 companies worldwide are using SDC Verifier software. I'll show some of references in the end of this session, as well as I will demonstrate some of the workflows of these companies. So what are we going to speak today? We are going to speak today about the workflow problems of structural engineering and how it is tackled by SDC Verifier. We have so in the progress of structural engineering process, there are multiple things to be taken care of. There is some designing stage, some drafting stage, CAD part of it. There is a simulation stage, which is becoming increasingly important, and now almost no products are developed without simulation. There is a compliance with requirements, of course, is a big part, with requirements of the standards is, of course, a big part of this workflow, as well as work with documentation, with lots of reporting, generation of the results, presentation of the results to your colleagues, to your customers, submitting result reports to certification societies, regulation bodies, or final customer as well. And all of those tackles require multiple tools, require a lot of repetitive, laborious routine, and require lots of knowledge. So what we are trying to do within SDC Verifier, and what we are successfully doing since 2009, sorry, for 15 years, it is a software to perform structural verification within simulation and do all the necessary pre and post processing actions to perform this kind of projects. So it is possible to on your screens, you see now the diagram of SDC Verifier workflow, which is formed in a loop because it is a repetitive process. SDC Verifier is the software that works independently, but also within ANSYS, within FEMAP interfaces, Siemens interfaces, and so on. Today, we are going to focus on the independent interface of it, and it consists of simulation. It consists of load combinations and taking into account all possible behaviors of the behavior scenarios of the model to run this simulation. It has a detection of structural items because it's very important within finite element analysis process. Multiple different checks according to all possible industry rules, not only Eurocode, but much more. Automatic documentation, optimization of the design, and this is a loop in which engineers are constantly finding themselves, and where the steps are in need to be repeated multiple times, because as far as you submitted in your opinion, final report, there might be changes, there might be design updates, modifications, and so on. And this is what we are facing, all of us, and this is what are the challenge that we have to overcome. So our goal is to overcome all of this within one product, which we call SDC Verifier, where SDC stands for Structural Design Checks, which has in it all of the steps of the engineering workflow directly in the product. So let's start. First things first. Somehow we have to get to our model, and there is two ways. Very often there is already a CAD file, drawing files, step file, 3D, some kind of 3D geometry, or even an existing FEA model, which has to be worked on. So SDC Verifier has the functionality to import drawings, to import geometry files, to import step files, or existing finite element analysis model from different type of files, as you can see on this screen, but also different other finite element analysis software. So if there is a model in any way, it is possible to import this into the interface of SDC Verifier to continue with the next steps. But sometimes the model has to be started from scratch. Therefore, the software has the functionality, and the software has all the necessary tools to build the geometry from scratch. So as you can see in this convenient graphical interface, you have your model to start working on, but on top we have a tab with all the geometry options. So if you're going to geometry options, you are able to create points, you're able to create lines, you're able to create surfaces or solids, and also do all the necessary operations with them, like editing, like revolving, reflecting, moving, extending, cutting, and all of that, with a very convenient interface, and everything is within one tab, so it's nice and easy to operate with it. But I agree that sometimes models are extremely complex but repetitive, so modeling can be parameterized. And for some of the industries we're working in, we have developed a set of tools for parametric modeling. So you can see here on the top right, for example, a parametric model of ship-to-shore crane, where basic inputs has to be, it was delivered for one specific approach where the design was set, and you basically have to enter like 10 parameters, and SDC verifier generates a complete finite element analysis model for you. The same we have recently repeated for some jacket models, as well as models of electrical towers. So if you have a repetitive modeling that is easy, or in your opinion, it's possible to parameterize and automate, this is something we can achieve with SDC verifier, because defining parametric models is so much quicker, and editing of those models, it's just a matter of entering one value. So I would gladly hear from you about your models in the end of this session, and how do you define them? Is this import of the geometry? Do you have your models within any other FEA tool already, or do you build your model from scratch? And are you benefiting? Would you think you would be benefiting from parametric modeling? After the initial stage of geometry preparation and modeling is done, it is necessary to proceed with building the finite element analysis mesh, defining the parameters, defining the materials, properties, and so converting our geometry file into a finite element analysis model. So this is defined within the meshing stage, and on the meshing stage, you're able to define all of the mesh attributes, such as the size of the elements, type of the elements, the parameters and properties of your elements, and it's done through this convenient interface, again, as you can see on top. So all the preparation, all the bodies, all the geometry actions to either create mesh or copy or edit mesh, as well as removal, of course, are available in this menu. Besides this, we have a very convenient interface of meshing toolbox, which has all the necessary preparation and geometry functionality to work with preparation of the mesh for your model. So this short video will show you how to quick and easy define the splitting of the geometry, adjust the mesh sizing, mesh with predefined settings, introduce some modifications. So as you can see, in a couple of clicks, geometry surface turn into finite element mesh with a decent size, where sizing can be improved. Some tools can be used to achieve a perfect rectangular finite elements grid, which, as we all know, leads to a perfect analysis results. So meshing is super quick, super easy, automated, and then your model is ready for defining the loads. SDC verifier is automating a certain type of load application for complex loads, like buoyancy load of water pressure of the floating constructions, or tank loads, or distributed pressure of winds, waves, and so on. So the complex loads are, of course, automated within certain tools within SDC Verifier, and application of the simple loads like nodal forces, displacements, temperatures, and constraints are done in a single interface in few clicks. But what is important for checks according to standards, it's not only it's not only loads, individual loads itself, but it's also the combinations of the loads. So every standard is coming up with a table like this, which has some individual influences like accelerations, forces, masses, environmental action, and exceptional actions combined in a certain way, with taking into account safety factors, partial load factors, coefficients, dynamic influence, and so on. And these are defined by standard, while SDC Verifier is allowing to build loading combinations to take into account all of the possible scenarios. So when you are going to review your results, it's not only under a specific loading conditions, but multiple loading conditions. Some of our customers are generating hundreds of loading scenarios, especially if you're speaking about the structure which is subjected to environmental loads like winds and waves, where you have basically all possible combinations from all directions. It ends up with hundreds of loading combinations. So all of these loading combinations are taken into account through the calculation core of individual loads, load sets, and load groups. And for specific standards like Eurocode, we have an automatic combination of loads, where user is only required to define a type of loading, and SDC Verifier builds the matrix of loads automatically. Then when our initial model is set, we are able to define, we are able to start with the analysis. So we have prepared our geometry, we have meshed it, we have applied loads and constraints, and we are able to run the solution. In SDC, it's done quick and easy within clicking one button, analyzed, and immediately the analysis is being run. And it is, we're not reinventing the FEA, it is powered by SimCenter Nostrum. So one of the most powerful and reliable solvers in the finite element analysis industry is embedded into this functionality. We have SimCenter Nostrum basic license, which allows linear static structural analysis, normal modes, vibration, structural buckling, steady state, heat transfer, and basic nonlinear. So all the solvers for basic finite element analysis are included in SDC Verifier. And there is no, it is not something it's not something new. It's developed since the 80s. It is a huge industry, the huge industry, and multiple different industries around the world are powered by simulations with Nostrum. So we are glad to have one of the best finite element solvers within the library of SDC Verifier. But then we have to perform checks, right? And finite element analysis is based on, again, is based on finite elements. So the idea is that if we need to perform the checks, we need to have structural members out of this finite element analysis model. So if we want to do a connection check or joint check, we need to define the connections within our model. If we want to do member check or beam buckling, we need to have one member which consists of multiple finite elements. If we need to perform weld checks or fatigue checks, we need to identify the welds. So all of these structural members has to be recognized, as well as plates for plate buckling, or panels, or stiffeners, or bolts. All of this are done within SDC verifier interface. So as you can see, you're traveling in our software through the steps. So you created a file, you have some basic settings, you prepared geometry, you did meshing, and now you're on the recognition stage, where you can define either to find everything or to find them one by one. And this is an example of weld finder of SDC verifier. I will play this short video where within a second, I think this video is slightly faster than supposed to be. Then within a second, you click one button, find, and SDC verifier is analyzing the complete model and defines for you the list of structural elements, which can be obviously modified, edited, merged, or splitted, as well as define some settings, define some parameters for extra calculations. So within the whole tool, we're giving you an instrument to perform different kind of recognitions and to have a full control over these recognitions. User is always able to add, remove, modify, merge, or split the structural members out of finite element analysis model. Yeah, excuse me. So what is the result of this recognition? As the result of the recognition, you get the list of elements that are supposed to form the structural members. And then the stresses in this welds, in this case, they are reoriented into the weld direction. The forces in this elements, if it's a beam member check, for example, they are summarized to be taken into account, or force balance in the joint is taken into account for further calculations. In the same way as we have recognized the welds on 2D models, it is possible to define the welds on 3D models. So if you have complex designs with solid elements, it is possible to run the recognition, and then SDC verifier defines the welds in your model, finds all the elements that are supposed to be welded. You can set up the parameters for this and run weld strengths, fatigue checks, and evaluate the welds. It is one of the recently added features, and it helps a lot for multiple users to run the checks related to welding. But besides welding, there is so many structural elements to be defined. One of the options is, for example, plates for plate buckling. So not to identify only the buckling factor and the first plate that is going to buckle, but to identify the buckling factor for each and every plate of the structure. Especially this is great for naval architecture and shipbuilding industry, where you have hundreds of frames and millions of panels. You will have a utilization factor for all of them and only indicate those that are going to fail, and the buckling factor for those. In the same way, beam elements for beam member recognition, for buckling checks, for membering checks, axial load, bending loads, combined influence, shear, and torque. All of this can be checked while you are identifying the beam members. So the recognition of structural members allows us, again, to have everything within one workflow and have everything within one tool. Next item is checks. So when we traveled further through our ribbon, next part is standards, and we are able to generate the checks according to multiple different industry standards and for different failure modes. So here you can see the tab of Eurocode checks that we have, and we have Eurocodes for members, for welds, for fatigue, for bolted connections, for fire design protection, plate buckling, and connections, global connections. Now we are also introducing the weld checks on 1D model for specific connection, like I-beam to I-beam, box to box, pipe to pipe, SDC verifier will be able to do checks on all types of even weld checks on beam elements, because there are certain types of checks that are applicable to certain types of elements. Obviously, you cannot do plate buckling with beam elements and so on, but in general, there is no limitation to the workflow to create this kind of checks. And SDC verifier, besides the European Eurocodes, has more than 40 different standards in the library of the software. So we have either regional standards like AISC or AIJ, Australian standards, and so on. But besides this, we also have standards for specific industries like American Bureau of Shipping or DNV, or API for petroleum industry. So total is about 40 different codes, and this library is constantly growing. This month we are having a release. Now in our library there is about 40 standards available. This, I believe in 2 weeks, we are having a release where we are publishing 5 new standards. So it is Bureau Veritas plate buckling, BV R615. It is Eurocode, this weld checks extension. Then we have new versions of American Bureau of Shipping codes, and as well as some extension in Australian codes. So there is going to be about 45 standards in the library, and it is not limited to that, because it's possible to create custom codes. It's possible to write your own codes. And also, we are constantly improving this database. So if you're missing something, if you need a specific check, we do some railway check now. We do some energy industry for electrical towers, some specific standards. So if you need some specific checks, it is either already being developed or can be moved in the priority of SDC verifier. So just let us know how we can improve this library to suit your requirements. How are these checks implemented? SDC verifier uses a simple plain code system to be able to use the parameters of FEA model, like thicknesses, geometrical parameters, dimensions, or material parameters like Young modulus, yield, or tensile strengths, as well as outputs of finite element analysis like forces, displacements, stresses, and strains. So we use them as variables to create the formulas. So there are material data parameters, property data parameters, user-defined characteristics, results from other checks, and mathematical functions to create these formulas. So the thing is fairly easy, because if you know how to write a formula in Excel, or if you know how to write a formula for hand calculations, it's basically the same. But the full strength of automated software with finite element analysis, Nastran solver, and detection of structural members makes it unlimited, and any kind of checks can be created and can be taken into account. After the results are analyzed, it is possible to, of course, present them in a tabular data. It is possible to present them in a colored plot, and so on. And it is, moreover, possible to build a template-based report which is explaining everything about your model. How is that built? What are the parameters? What are the results and outputs? It's done in a very simple yet convenient tool, which helps to set up your template of the report, define the views and portions for the model, define the structure for the report, generate it, and export to Word document or PDF document. And then you have a very nicely structured calculation report having the tables with results of forces, stresses, displacements, as well as check results. You have multiple colored plots of different different results, and it's again export. It's easy to navigate because of the template-based procedure. So it's possible to structure everything and copy the structure between different individual loads or load sets or load groups that we have created on the previous stages, and it's easy to navigate through it. But of course, your results are not perfect, very often not perfect from the first iteration. That's why we have a design optimization based on structural engineering rules. So you can pick the best design decision for beam element cross-section, plate thickness, based on material parameters or based on weld type, and run the check multiple times to pick the best possible design decision to comply with requirements of the standard. So if some portion of your model is having too high utilization factor, it is possible to define the replacements and see what is going to be the optimal results, not to be too strong for material overuse, but still fit into the requirements of the standards. So instead of guessing what should be the correct result, SDC verifier allows you to optimize the design and pick the best design decision based on the requirements of the standards. It gives you a full FEA analysis capability, but sometimes you need even more. So you need to expand into some advanced structure types or different analysis type. And there is no limitation because SDC verifier has a possibility to export whatever was imported and post-processed and analyzed with SDC verifier can be later on exported back to another program. So we have lots of integration, and it's possible to export back to the full FEA. This forms an unlimited solution, which gives a possibility to run the simulation based on excuse me, I have to, yeah. So which gives you a scalable solution. Excuse me, I have to answer the message very fast. Yeah, sorry for that. So which give you a scalable solution which works independently, offering everything: simulation, structural analysis, calculation, code checking, importing capabilities. You can skip multiple transitions between dedicated design software, modeling software, simulation program, code checking program, report designing program, and have one tool to simplify the workflow, to automate the workflow, to define everything within one interface. There are different levels available for the software. I will focus on that a little bit later on. So it's possible to have beam elements only, or beams and plates, or full FEA with multiple functionalities. But what are the benefits that this workflow is bringing to the engineering world? We have had some study with our customers, and they have given us the results on their real-time projects. And for the hand calculation, you could see that the time benefit was like it was possible to save 80% of time for the specific project compared to a hand calculation. In work with the standards, with SDC verifier, it was possible to do it. Let's say if we see this, it's 15 hours out instead of 40 hours. So it's in a work week, you save 3.5 days in one work week on working with standards. Reporting is significantly automated, and you basically do it in no time compared to doing manual reporting. And it's only comparison of preparing the report with SDC verifier. In preparing the report, within a dedicated tool. But at the same time, SDC verifier is saving time on repetitions. So when something has changed in your report and you did it manually, you will have to redo all the work. With SDC verifier, it's 3-button click. So overall picture looks like this. SDC verifier helps to save time on different steps of the engineering projects, on working for different designs, on reporting, on assessment of the results, on the analysis itself, analysis for different types of models, load application, a preparation of the FEA model with the powerful tool of meshing is the same as, well, meshing is almost automated everywhere now, so SDC verifier helps with that a lot. Hand calculation are saved. Load calculations, to that one I wouldn't agree because I believe there is at least 50% of time saved, and working with standards is significantly automated. So based on the feedback from our customers, it is we have learned that now they are saving about 50% of the time for modeling, analysis, and generating the report in their structural engineering projects. So where is this applicable? SDC verifier works with multiple industries where, as I mentioned at the beginning, the compliance with the requirements of the standards is very important or even mandatory. So it's energy industry, it's oil and gas, it's civil engineering, especially with beam checks. It's a simple and effective solution for a reasonable price to do checks in civil engineering, offshore, maritime, shipbuilding, naval architecture. It is applicable in machinery and equipment. If you work with lifting devices, it's also good for you. We have standards for aerospace, piping, petrochemical, railway industry, renewable energy, defense, and moreover, because with open interface of standards, it is fairly unlimited and possible to use for multiple different applications. Who are SDC verifier users around the world? So as I mentioned, we are developing this software for 15 years, and multiple companies around the world in not only structural engineering, but design domain, equipment manufacturers, equipment operators, as well as certification societies like Bureau Veritas are users of SDC verifier standards. Multiple different industry, multiple of big names. So if you work with companies like ones of those listed on this slide, you will probably also learn how they use SDC verifier, where they use SDC verifier, and how is that applicable to their projects and to your projects, therefore. SDC verifier comes in 2 versions. It is possible to have it in professional version, which has all the functionality, all the recognitions, and all the checks, or enterprise version, which comes with extra automation, optimization, advanced tools like hotspot stresses, rainflow counting, and so on. It is possible, as I mentioned before, to have it limited on element types. So if you have only beam element models, it's possible to get a limited version of the software with beams only. If your model is more complex and you need 2D elements, you're able to add 2D elements and do beams and plates with 1D and 2D elements, all the standards necessary for that. All in enterprise version, you will also have optimization on that, automation, and so on. And if you are an advanced user with all types of checks and all types of finite elements, it's possible to have full tool with hotspot stresses, rainflow counting for fatigue, all standards for verification, all recognitions, all detections, 3D modeling, optimization, and more of that. So with this, I'm trying to say that pricing of SDC verifier is very flexible, and everybody can find their functionality, their licensing levels, and the option for them. For this, please reach out to Alessio and to Enginesoft team to help you, as well as if you need a dedicated information, I'm also always available. For this, at this stage, I would like to summarize. So what is SDC Verifier? It is an all-in-one software solution which helps you to do a structural design, which helps you to perform the finite element analysis and verification according to rules and regulations. And specifically for the attendees of this webinar, I have a special offer. We are able to provide a 10% discount by the end of Q1 if there is a legitimate interest and need in this kind of software. It is possible to get it at a discounted price now. Contact please with Alessio or send a message to me, and I will gladly assist on acquiring this. And with this, I would like to conclude this session. On your screen, you see my contact details, where to find us, how to call us, or send me an email. Please also connect with me on LinkedIn. I post a lot of interesting information about structural engineering and finite element analysis, as well as SDC Verifier news over there. So I will gladly connect with you on LinkedIn. And if we have any questions, I am happy to answer those questions. We still have some time for Q&A session. Thank you. And Alessio, I am, yeah, if you have any questions in the list, please let me know.
Thank you, Oleg. It was very, very clear as usual, and thank you for your brilliant presentation. Also, this great new software, new in a sense that now we are moving on a standalone version of SDC, and I kindly ask if someone has some questions. In the case there will be no questions, feel free to contact me at the Enginesoft or also Oleg that has given his references. And okay, for our side, I think that if there are no questions, we can
yes, questions
go.
usually appear when the engineer starts to work with the software.
Yeah.
Trial version is available. Demonstrations, dedicated demonstrations on specific models are available. So we are we will gladly provide you with more demonstrations and information. Just contact with Alessio or myself, and we will proceed from there. Thank you very much for your time today and for your attention, and I'm looking forward to working with you in the future. Thanks.
Thank you, Oleg. Bye-bye.
Bye.